Okay, hello everybody. Starting from my last video, I realized I hadn't actually talked about something which is quite important, or at least it's a useful trick you can do with this basic idea of having a channel and using a channel for synchronization. So what we're doing here, if you want to have a bird's eye view, is outside of this channel, you can have lots of threads doing lots of things at the same time, and the channel acts as a bottleneck, which allows just one thing to come through at one time. However, we still have the problem that we can't actually that we can call. We have these three commands defined here. We have an add command, a contains command, a get command, whatever. There's certain redundancy in these commands, of course. So another interface would probably be a good idea. So we have these three commands, but we can't actually use them to solve any race conditions at the moment, because there's a gap between each command. It's possible while thread A wants to find out if a value is in this cache. So thread A issues a contains command, and then thread B issues an add command, and then adding the value to the cache, and then thread A thinks, because it gets a response from contains command saying there isn't anything in the cache, he'll think, okay, well, let's just carry on and do something, and do what we would do if there was nothing in the cache. So we haven't actually solved the problem we wanted to solve by having this channel. And one thing I did automatically, which is a hint as to how to solve this problem, is that the loop itself gets as a parameter a channel. And when it starts with the default channel, with the channel which is created when you create this structure, and is saved here. But there's no reason why you can't start the loop again on another channel. So you can imagine so let's write a fourth command, which is going to be in transaction. We can call it like that, or in its own channel, in its own little sub loop. And what this does is this just takes a channel, which is going to be an in channel, which is, from the point of view of the loop itself, the channel which you're going to take anything out, going to take something out of, and this sends a command. It's a channel of commands. And then you can add this to the list of things we process here. So case in transaction, and what you do is you just start loop again, using the in channel from the transaction. Hang on, we're defining this incorrectly here. There's a channel you can only read from. Okay, good. So what this means, let's say you want to do something in a transaction. Like we have this, let's say you want to only increment if exists or something. My struct increment, we're dealing with a map of strings to strings, aren't we? So increment's not the right idea. Add string if key exists. Add string to value if key exists. Then you can have the key, which is a string, and the string to add, the suffix, let's call it suffix, if this key exists. So let's add suffix. That sounds like a better way of putting it. What we can do now here is we can have our in channel we create. In channel is equal to make chan command. And now we have to be a little bit careful about how we deal with this. Let me think, what's the best way to do this? Let's have a go here. Let's do this in its own thread, and we're going to an in channel, and we need to have a contains structure, so we need this contains command. Unfortunately, we can't just use m here. We have to write this whole stuff again, but we can find other ways to do this as well. Let's do it this way to begin with. So we have contains channel is equal to make chan pool, go func, in channel contains command. We're looking for a key, and the ret channel is contains channel, and then we wait for a response. We get the response. Exists is equal to, we're reading from the contains channel. Then if exists, let's do a add suffix. So let's get it to begin with. Yes, there's a certain redundancy here. Ret current value channel is equal to make chan get response go func m dot not m dot ch in channel at get command k is key ret channel is like this ret channel no, we don't call it, what are we calling it? We're calling that current value channel. Okay, and then we perform that, and we say response is equal to, current value is equal to the value which comes out of the current value channel, and then we just want to set it. Have we got a set? We've got a set somewhere, haven't we? Got an add command. I think add will work for set. Yeah, it just sets the value no matter what. Let's just send the add command. In channel add command. The key is key, and the value is this is current value plus suffix. Okay, so now we have shut that. Why doesn't it like that? What am I doing wrong here? Because get response and strict. Oh, current value. Get response. Current value channel. Dot. Now we've got to get it out of the current value channel. Hang on, what am I doing here? What am I doing wrong here? Current value is not a get response. Channel get response. Make chan, yes, not make chan get response. It is. Current value. Where do we put it? It's a structure. Okay. It's a structure of response val okay. Yep, okay. So get response dot val. That's right. Sorry, I forgot we did that. Okay, good. And then what do we need to do here? Well, all we need to do is we need to wait for this to run. Then we need to send it, don't we? Let's do this. So we create a what do I call it? A transaction command in transaction. Okay, so we send this inside. So m dot channel at in transaction. I think I made it small. So I did. Okay. And the only thing we have here is a it's a channel, isn't it? In channel. Okay. In channel is in channel. And then after this is performed, so here at the end of the go func, we close the in channel, and then we don't actually return anything. Okay, this is a basic idea. Let's see if I got this right, or if I managed to get stuff wrong. Let's test this. Test in transaction. Yep. Okay. T testing.t. So let's do two things. Let's m is equal to new my struct, and the idea is that let's add one thing. M dot add foo bar. So we've added one thing to m. Now we're going to do an m.add suffix if key exists, and we're going to try for foo2. We're going to add the suffix of a suffix, and we're going to add for m.add suffix if key exists. We're going to do the same thing for foo. Another suffix. Let's have different strings so we're totally sure. And let's log what we find here. So let's dot a t.logf current value of foo is a m.get, what do I call it? Get foo t.logf current value of foo2 m.get foo2. Okay. What does it look like here? What am I doing wrong? Two valued in v. Oh yes, it returns two things, doesn't it? Can I do this? No, Go doesn't like that. Okay. So response val OK is equal to m.get foo. Then we can print val OK here. Val is going to be a string and OK is going to be a boolean. Let's put these in their own little scopes so I don't have to worry about this. Let's make a function even. Func show val string val. So val string. Too much Java programming. That's in key string. Too much Java programming recently. And m is a my struct. And let's just paste it here. Let's get rid of this. Cut, and we need a t. T testing.t. Okay. M.get string. String key. Oh dear me. Current value of key. Okay. Let's do this here. Show val foo mt. Show val foo2 mt. Let's insert these here, and then we'll see what's gone wrong. Okay, and let's go here and let's run this. Okay, why aren't I seeing anything? Ah, because I'm running the wrong test in transaction. Okay, there you can see it running. So you can see to begin with, these two are coming from the first. I'm happy this worked. These two are coming from the after you've added foo, and you can see the value of foo is bar, and it's set to true. Foo2 as current value is the empty string, because the default value of a string in Go is the empty string, and it's false. The current value of foo after we've called add suffix if exists foo2, then foo hasn't changed and foo2 hasn't changed. But when we add the suffix to foo, which exists, then foo gets changed into bar another suffix, true, and foo2 doesn't. So this is one way to do things inside a transaction. Another way to do this, have a mutate command. We thought we'd write a mutate command. And the basic idea of the mutate command would be that it you can either process a mutate command inside its own thread here, or if you want, one other trick you can do, which will make life easier, because here we're sending lots of commands and producing lots of threads with the add suffix if key exists. What we can do is we can take the meat of what's going on here, the idea of adding a suffix if key exists, and rather than make all this code here part of this public, all this code here part of the public function add suffix if key exists, what we could do is we could create a private function as a helper function, and it takes a key string and it takes a suffix string, and what we would be able to do here is we would be able to say that this function is called from behind the bottleneck. So we'd create a new command type. Let's call it, what do we call these commands? Add command, contains command, get command. So it would be, sorry for the long name, and suffix if key exists command, which is a struct which has a key and a suffix, which are both string. Then what we do is we just process it here. So VOK is equal to m.cache key if OK v m.cache key is equal to m.cache key plus suffix. So that's what we do here, and instead we got this v, haven't we? We can use the v here. Then we'll be saving a cache lookup. We'll probably get cached anyway, somewhere in the system. And then we would add this as a command here. So case add suffix if key exists command. Then we would do a key suffix is equal to f.key. Actually, we don't need to do this, don't we? Just to do an m add suffix if key exists, v.key, v.suffix. And then instead, what we do in this large external command is we just do m.channel, we just give it an, add suffix if key exists command, key is key and suffix is suffix. And that's all you'd need to do. This would disappear. And this, if I did it correctly, will do the same thing. Let's see if I got this right. Why is it not? It's a little bit unhappy with me now. Okay, now we're there. Yep, this works as well. Okay, this of course looks a lot nicer. So we're doing the processing behind the paywall, behind the bottleneck. But the technique of adding a channel, so you can do whatever you want, is actually quite a nice idea. I'd have this idea of a transaction. It works quite well, and you could. I'm trying to think. Yes, you could probably create. Yes, you could find a way to create a structure, a my struct, which contains the same cache as this one. At which point, you'd be able to have the idea of create child my struct or something, or create my struct with different channel. And you would call that here rather than just calling it m.looped directly. But one thing to notice is that this is not in a goroutine, this m.loop here, which means that this function, that means that the loop function gets called again with this channel, and the code blocks here until the loop function exits, which means that no one else can send an add command because no one's reading at the moment. The code's blocked here, so you won't get around to reading from the channel. This line won't run again on the original channel until this m.loop, until this call of m.loop with the new channel has terminated, which means that it terminates only when the new channel here gets closed, which is how this works. Okay, let's go back here because I think this example is a lot more interesting. Let's put this in parentheses, so to speak. Which was just an m.channel add suffix if key exists, key was key, and suffix was suffix. Just so we don't forget that this is also possible. Command. Okay. Not an m dot. What am I doing here? Okay, good. What's the next thing I want to talk about? I wanted to talk about, if you can see down here, data comes from another source and is cached in the MyStruct cache. So let's say we have a different sort of cache here. Do I want to do this in this video? Maybe I'll do this in the next video. Okay, yeah, let's get this one uploaded and I'll talk about that maybe tomorrow. The basic idea would be, what I'd like to do is in the background for this loop, I'd like to start a thread which triggers every 2 minutes or triggers every 3 minutes, and then calls a new version of the data, checks the web service to see if the data has changed, for example, and then downloads it and caches it inside the MyStruct cache here. That would be the basic idea. So for that, you wouldn't yet need a select statement. You could do it all inside this one loop. Actually, no, this is quite an easy thing to do. Let's do this. Let's say the cache, we don't have an add command, don't have a way to modify data. The only way to modify data is to get it from the web service. Let's do it like that. So we've got a func poll web service or download new data from web service if necessary. Okay, and this of course is a function as a method on MyStruct, and the basic idea, let's go m.download new data from web service if necessary. We would have an infinite loop, and then we would just do a new data error is equal to get data from web service, which is a function which comes from somewhere, who knows where. Get data from web service dot dot dot, and this returns let's just say it returns a map of string and an error. Let's have it return nil a moment. If error not equal nil, do some logging, log dot print f. I don't have a logger attached, so we're going to have to do it like this at the moment. Error getting data from web service in MyStruct. Error. Hang on. Yeah, it's going to be okay. Let's do it like that. Else m.channel replace struct command to replace struct command new, so struct not struct replace cache command. Cache is equal to new data. Let's create a place cache command, type place cache command, struct cache is a is a map of string to string. And that's it basically. And you have this loop here, we can add it here. Case replace cache command, m dot cache is equal to a v dot cache. That'll be the basic way of doing this, and have this running in the background. Let's have a pause as well, so time dot sleep 2 times time dot minute. That's going on in the background. So every 2 minutes it will poll. So the question is, how do we stop this now? This loop just goes on forever. Don't want to talk about how to stop this now. We're going to get into contexts now, because the context is the typical way you would stop this. Yeah, let's get onto a context. I think this is a good idea. Let's add a context dot context. Let's get on to context. So usually you pass context onto in as a parameter. Maybe I should explain what a context is before we do anything else. A context in Go is usually used as a. Let's show you what you can do with the context. First of all, ctx.done is one command you can call on a context, and this blocks until the context has been cancelled. Another thing you can do is you can inherit from a context. So you can have a context dot with cancel from a context, and the base context is background, by the way. And this will give you a new context and a cancel function. What this means, so let's say we have this, let's say you have something fanning out. So you're in one function, you're starting 5 different things, which all need to be coordinated. Then you could pass them all the same context as a command, and then as a parameter, and then someplace inside the context, inside this function which is being called, you would wait for context.done. And if context done, then that which you've called will be, the function we've called will return. Let me show you what that looks like. Rather than having a for here, now we can have a for. What we'd then do inside is you'd have a select statement with 2 cases. Time dot after 2 times time dot minute. Now we're reading from it, aren't we? So this will have to be like this. Then we would do this dance here. However, case m.ctx.done return. Okay, what isn't it like here? What am I doing wrong? Oh, better. Good. Okay, so what we're doing here is we have an infinite loop, and inside the infinite loop we have a word select. It's the first time that I've used the word select, and it's used a lot when dealing with channels in Go. And what a select does is a select it's rather like a cond statement, or a switch statement. I think in Go it's called switch, isn't it? It's rather like a switch statement, but it switches on channels rather than switching on values. And what it does is whichever one of these cases becomes true first, go into that block. So in this case, it either waits 2 minutes, or it will trigger on context.done. Let's put this in front so we're actually always doing something. Put it there. Okay. So we start by refreshing the cache, and then we have the select statement, which either says after 2 minutes, go into another iteration of the loop. Case in Go does not have an automatic fall through. It's not just a label, like it is in C, by the way, or in Java, unless you're looking at Java 17 or something, which is a new syntax. However, but if the context gets cancelled from outside, so whoever creates the struct, we need my struct, will keep a reference to the CTX, and at some stage call this cancel function, or find a way to cancel the context. There are lots of ways to cancel the context. The context can have a timeout, so it automatically cancels after a certain amount of time. A context can have a deadline, so it cancels at a certain particular moment in time, like 2:15 p.m., whatever. Or a context can have an explicit cancel function, so that whoever has control of the cancel function can call it. So whoever owns the cancel function can call it, which will cancel all of the context and all of the child context from this context at the same time. So what this does, download data from web service, if necessary. After 2 minutes, it will either loop again and get data from web service, or it will go into m.context, or if before these 2 minutes are up, the context is cancelled, then it'll just return. We will leave this loop. Now you could of course say, well, if we're using this context here to cancel, if we're using this context, which is the context we pass into my struct, to cancel this goroutine, why don't we use it to cancel this goroutine? Well, of course, using it to cancel this goroutine, why don't we use it to cancel this goroutine? Well, of course, we can. There's nothing stopping us doing that. Rather than having a for command in the range channel, we can have a for and an infinite loop, and then we can have a select here, and we can have our case command channel, and then ... do stuff here, or we can have a case m.context.done return. If we do it like that, then we don't need an explicit destroy. Well, because we'll be breaking out of this return loop. We'll be breaking out of this loop, and the goroutine will automatically be collected. Will not have to be garbage collected, because there'll be no way, because there'll be no reference to it still there. So we don't need an explicit close. The channel will automatically, when we break out of the loop, then everything will fall out of scope, and the channel will also automatically be garbage collected. Of course, if we do it like this, then we can't use our traditional way of exiting a loop, which we used here at suffix if key exists. We had this close in channel. We wouldn't be able to do it that way. We wouldn't get out of the loop this way. Instead, we just loop again in here. Actually, in this case, if we called close, we would start looping infinitely fast, because a closed channel can be read from immediately. It just immediately returns nil. So this would start turning as fast as the Go runtime and the hardware allows. So this is not the way we decided to do this to begin with. So let's get rid of this. And maybe in the next video I will build everything to use contexts to cancel, to get out. The basic idea is we'd have to also provide a context here. as an argument, so we know which context is used to cancel what. Okay, cool. This has been quite a long video. Hope it's interesting to someone. Talk to you all soon.